Welcome back, guys. Today I am doing this video on how to design a parapet wall. This is a follow-up to the last video I did about how to design a hidden gutter or an internal gutter within the Kenyan context. So the aim is just to point out some of the things these young guys who are building in Kenya are doing, or they could do better, seeing as they're spending quite a lot of money building these mansions in their villages, which is a big achievement in and of itself. And as I said in the last video, it's very, very expensive to build in Kenya, especially when you don't have access to a mortgage. And a lot of them, all of them are actually doing it out of pocket. So the aim of this video is basically to just point out some of the things they can do better at this construction stage, so that further down, when they've occupied the houses, the repairs are not so expensive. So they wouldn't have to do the repairs as much if they can take some of this advice. So basically it is to try and save them a little bit of coin and money here and there. So in this video I'm going to talk about how to do a parapet wall, which almost always accompanies an internal gutter. So I'll just turn around and show you what they are doing so far, and then just as in the last video, I will point out what they are doing right and what they could do better. Right, so we're just back on the same sort of house that they're doing. I'm just using it as a case study and taking out just a few shots. I hope they don't call me out for copyright infringement. I doubt it is copyright infringement, but you know, let's watch.
Today the main job, they are now covering the places around to prevent the leakages. Like I think now they have to fit here by using waterproof and everything, so that we can have a stable house that does not leak. Guys, I'm happy. I'm really happy. I'm happy. Guys,
true or false question. When you're fearful or have uncertainty, your confidence is down. True or false? Absolutely true.
So I'm just waiting for this advertisement to end, but this is what I wanted to show you.
what they have been doing
What he's talking about.
is now tightening the roof. Tightening the roof. So guys, this is how the roof looks like. It's a rip. Not tell the main. Is now tightening the roof. Tightening the roof. So guys, this is how the roof looks like. It's really, really beautiful. So beautiful. I'm just standing on top of this roof, and guys, thank you so much for giving me a present. Thank you for everyone who has been supporting me, encouraging me right now, encouraging me, liking my videos, working on the roof. It's advisable that you walk in places where there is the nails. You see here, where we have the nails, but I don't want to walk much here so that I don't destroy the roof, because it's still brand new. So today the main job, they are now covering the places around to prevent the leakages. Like I think now they have to fit here by using waterproof and everything, so that we can have brand new. So today the main job, they are now covering the places around to prevent the leakages. Like I think now they have to fit here.
So my main issue really is this part here when he talks about covering the leakages, and you can see from the video how they are covering the leakages. This is they're probably using waterproof cement, and it's definitely going to, there's already cracking happening in there, And even if they remove that and start and put in a fresh coat of waterproof cement, the signs of leakage, it will still crack after some time. And really that's what I wanted to point out, because it's very important how you detail this particular area so that it's completely waterproof and there's no leakage. Let's just continue and see what he says next.
By using waterproof and everything. So brand new. So today the main step they have to repeat here.
Yeah, so clearly, of course, you gotta forgive him, because he's not a contractor or a builder, so he doesn't necessarily know what is supposed to happen. And like I said, they have used tiles on this parapet wall, which I still question why. Maybe they have a reason. Maybe they are they are robust and good tiles for that particular purpose. But I've never seen a parapet wall that is tiled on the external. But be that as it may, the other thing I want to point out is when he talks about walking on the roof, right there, that roof basically, if it has self-supporting underlay, that roof should be designed such that it's walkable, which means that if he says he's only walking where the nails are, which means that's where the roof purlins are, and then it means the spacing of the purlins is quite questionable because it's leaving too many, such a large gap between the purlins, and you wonder probably how those nails have been nailed in. Normally you would have a flashing or a washer and then a flashing around the nails, just to prevent any water ingress through the holes that the nail has made. Or you can come back and then seal it properly with some waterproof seal or something like that. But we don't see that here. So that's again another point of worry for the future when this house is finished. And I can guarantee that the fixing of this thing, a leaking roof, is not an easy job, and it's a very expensive job. So if they can do it now, seal these nails, come back and seal these nails somehow. Like I said before in the other video about internal gutter, they didn't use underlay. So when it leaks, whenever these nails will start leaking through there, the water will go directly into the ceiling, and then eventually down into the spaces, into the habitable spaces. So it's quite, to me, it's a bit concerning that way. But look at this place here. For the purpose of this video, you've got this little corner here. It's like a pig's ear sort of situation, which is really not good at all. I don't know what is happening here, because there should be a sort of some channel here, but you can see they've not, where this roof right here, where this roof meets the walling here, they haven't really done much other than smear plaster there. I assume it's waterproof cement plaster. They've just smeared some of it there. What will happen eventually around this area is that because of the difference in temperature changes, the heating, expansion and contraction, this one here will crack, and then eventually the water will go through. So this is a point of weakness straight away. These funny corners, especially, they need to be really flashed properly and detailed properly, and I'm not sure they've done that. So let's watch a little bit more.
When walking on the roof, it's advisable that you walk in places where there is the nails.
Yeah, so really for me, this is what is concerning, because you see the grooves in the metal sheets. Ideally, you want this one right here when you're finishing along these edges. You really want to have a flashing here, and then you really want to tack, even if, let's assume you're using tiles, even if you're going to use tile, you really want to tack this piece of metal sheet here vertically behind the tile. So you fold it at least up to, say, 100 millimeters up, or actually even 50 millimeters up minimum. You fold it, and then you put your tile over, you know, and then you can put waterproof, and then you put a flashing there that will come, so the flashing will go up again about 100 mils, and then come back down here, and then overlap maybe 2 grooves up to somewhere here on top of that, and then the tile then comes on top of the flashing. That way, if any water was to come through like this, the water will definitely fall onto the flashing, and then it's directed onto this sort of particular groove. It's directed onto one of these channels, and then into the internal gutter, and then outside. The other thing I notice is that this parapet here, I'm not sure if it has a slope. They are using, this looks to me like, this bit here looks to me like, on the edge here, it looks to me like a quarter round aluminium beading, where they are using that to join the top tile and the side tile. And ideally, you want these tiles to have a slope, at least 5 degrees, falling from this being the top side. So this being the top side here, you want these tiles to fall from this side. I'll just make that, yeah. So you want a bit of a slope from this side of the tiles, this being higher, and then falling this way, at least 5 degrees, so that any water falling on top of this parapet wall is directed straight down into an internal gutter here. But what they've done, I'm really concerned about this bit here. What they've done here is that they don't necessarily have a channel, so I don't know where this water will go. You see, this one big, actually this is one big mistake right here. This is glaring. This is gonna cost them quite a bit, because there's no way this water is gonna come down here at a great speed, then it would splash back on top of here, and then it will have to find a way to sort of get into this pig's ear kind of situation, and then into the gutter. So unless they find a way to sort of cut this back, but they do have a purlin here. You can see the nails nailed here, so there's a purlin here supporting this roof. So the cutting back again means that the water will actually, when it splashes, that will actually fall back and damage the purlin. So this is going to be, it's quite a dangerous situation. I'm not sure how they're going to do this, but you know, they needed to actually have created another little gutter here, around here, and then maybe push this purlin back up a little bit, so that they have at least 300-meter wide of gutter, and then flashed this parapet wall down here all the way, so that that water comes in, even if it bounces back on, it can hit the flashing and back into the gutter and down that way. But they haven't done that. So this probably if this is not rectified, this is a big mistake right there, and unfortunately. But enough of that. I will turn around and then I'm going to show you now what they can do, hopefully to rectify the situation. Yeah, so again, I'm not sure about that aluminium beading, but you know, it is what it is.
Much here, so that you don't destroy the roof.
Yeah.
Because it's still brand new. So.
All right. Okay, so I'll show you in terms of drawing what that whole situation looks like. Let's see what we got here. Right, so back to my drawing again. So basically, in terms of drawing, this is the situation they have. They've got what I assume is really, that is your block wall. They construct using blocks. I assume that is about 200 mil wide blocks, which is really normally the standard, about 200 millimeters. And then on top of the wall, of course, they've got on top of the wall they've got a tile, and then of course I'm assuming the tiles they hold it onto the wall using grout, and then they've got that quarter round aluminium beading to connect this top tile and bottom tile. My own idea would have been to actually just take the tile all the way across and even do a sort of an overhang like that if I could, and then, you know, maybe put the beading sort of down there like that, in a different sort of way, not that way, but maybe something like that. I'll probably do something like that. I don't know. If I have to, I mean, very rudimentary, but I'm not sure even this can work, but I'll show you what can work. I'm just trialing out this idea. Now, if we do that, you see, if the water falls, then water will still come back. We want something to direct the water that way. So I'll probably change that beading to something like that, you know. Maybe something like that. So it directs the water at least further away, and do the same thing this side. I mean, if you really have to do that, but I don't think even this is the best way to do it. I would do probably even a metal angle line or something like that. Maybe direct the water that way or whatever, but be that as may, that's what they have. So what they have there is the other scenario. So that's sort of the scenario they have, and not that this is flat. They've made that flat. I'm not sure it's sloping at any time in any way. So there's no way water can drain off that. And of course they've got select tiles down below, and then this is the situation we have where the metal roofing is meeting the tiling. So this is how they are sealing it. So they've got waterproof cement, and it actually doesn't do that because they've got it all they've got the waterproof cement all up like that. Hold on a minute. They've got the waterproof cement doing something like that. I just all up, you know. Yeah, so I think they're just plastering the waterproof cement like that, all up, and probably this tile is coming all the way down. This tile is coming all the way down there, and then they're sort of sealing that like that with waterproof cement, which is very basic and very rudimentary. This is a point of weakness. I've just written here when I was analyzing this that is one point of weakness, because eventually the waterproof is cracking. As we've already seen in that video, it's starting to crack. So it doesn't matter how much they patch it up, it's gonna crack anyway, and then water will start ingressing. Water will start just going through there, through those gaps like that, you know. And then even here, I'm not sure about this aluminium. This is a point of weakness because you have to use grout here and there, and when that grout starts cracking, then you have water ingress right through there and right through there. Eventually that grout just cracks and peels away. So, you know, so then you start having water getting in there, and this one will just trickle all the way down. That water will just trickle all the way down like that and into the living space under there down below. Or even get absorbed by, some of it gets absorbed by this timber, and then it starts to make the timber to rot, and some of the water of course comes in through there doing the same thing, and then it causes the timber to start rotting. And eventually, if you have your ceiling probably somewhere there, if your ceiling is somewhere there, the water of course will get right into this ceiling, and then when you look up, you start noticing puddles, some nice patterns up above in the ceiling, and before you know it, the same water starts to fall into your living space, whether it's a lounge or a bedroom. You'll start seeing the water coming in there. So this is like I say, what they're doing is quite a basic and rudimentary, but the question is, how can they do it better? So in this particular video then, I'm just going to show you this detail that I quickly sketched up on how I think currently they can improve what is there. You know, it's probably too late to rebuild, so how can they just repair what is there before they go too far? And what I've done is then what they can do, number one, is just create first of a 5-degree slope which they can chisel out of that concrete block, falling inward. So you've got that 5-degree slope falling inwards towards the roof, and then instead of using that aluminum beading, they can just do a gutter, the tile to overhang. I'm sure they can cut fine. I mean, this wall is 200 millimeter thick, so they can get a tile that is 250 wide and then just cut it so that it overhangs the wall by a bit, and then the other tile comes underneath like that on either side, and then Of course, they will need then to use waterproofing cement or sealant, or when joining the tiles to the block, and then down here, and then here, I suppose they could create some sort of diverter, but I'll come to that later. The most important thing is that joint we looked at. I'll just go back to that video and show you what they can do to rectify some of these things, which is that joint there. Yeah. Oops. I want to show that particular tricky joint there that can help them. Is that one there, but has to gotta look at it properly there. Right. Yeah. Or even there. Yeah, right across there. How to detail there. That is a good one to look at, but as well this other side. This is the most critical part, I would say. Yeah. So how can they detail this bit so that it is robust? What I'll do, I'll bring up my detail and I'll show the issue. Put this one here, and then we can go step by step. Show you guys what they can do. Okay. Now this is not. Let me see if my computer skills are what. There we go, and I can. Where's my? I can do this. Okay. Right. Now, okay, here we go. So to waterproof here, they could easily, before they go too far, this is the bit I want to highlight. So what you do is that you get an aluminum flashing, and then they put an aluminum flashing 200 millimeter minimum long, which can go over 2 troughs. So in this case, it can start from here, cover here, and up to there, and it will be sloping, and then this aluminum flashing will be tucked behind the tiles. So they have to tuck it behind the tiles. So what they can do is remove the tiles first, and then create custom make this aluminum flashing It can be stainless steel, and like I said, with stainless steel, even in the local town, they can get a Juakali guy to actually prefabricate a stainless steel flashing. 200 mils minimum across, or over 2 troughs. So say from here it covers 1, 2, maybe they go up to, I'll go up to there just so that I'm in line with that particular corner there, or kink. And then bring it back up and then tuck it behind the flashing, tuck it behind the tile, and then chisel into the wall just about 20 mils. This chiseling into the wall is just 20 mils from there to there. That's 10 mils. So I'm just gonna make it about 20 mils. You see, yeah, so chisel in there about 20 mils or whatever, just make it a little bit larger there, and then pull it back that way, and then just grout it out. So you just seal it with a waterproof grout or waterproof cement or something like that. You know, so that means the flashing is held tightly behind the tiling, and then come back again and now put your tiles over there. So now you put your tile over the flashing like that, and then just make sure this last tile is at least 35 mils above the flashing, and your flashing goes at least 75 mils minimum into the, before you chisel it out into the concrete. And what this sort of design does then is that when this water or any water is coming through, when it rains like that, as it will at some point, when water is, I'm just trying to get my thingy bob. When water is coming through like that, if that is your rainwater coming through, what happens, just bear with me as I indicate some rainwater. So if you have rainwater falling like that, the effect is that the water will just hit the flashing and it cannot go back up. Once it bounces, it cannot go back up like that. It can't go back up into the wall. That's one thing. And then the other thing is that because of this flashing here, because you have a flashing there, the water will not penetrate. Just a moment, guys. I changed that to bluey. Yeah, so the water will just hit back, but then it doesn't go back up into the tiling, and neither can it penetrate into the wall, and down there it won't be able to penetrate down there as well. So that one basically just protects, that flashing there protects your roof from being damaged. And then of course on top there, that is right there. I'm not sure, again I must say, I'm not sure about using tiles on top there. They are quite brittle. Unless they've invented something else, some sort of different kind of tiles that is, you know, robust and all good with all this sort of setup. But in terms of just waterproofing this corner, you do air flashing like this, so that flashing will come under these tiles and then back up, and then chisel it inside the parapet wall, and then over over the roof, and then that means that and then you do the same. So you do another. Now in this case, you're gonna have to do a side of flashing here. So one that will come over here and then over that, but then they'll have to be, the two of them will have to be joined together somehow, like that, and then like that in the corner, and then slope this way. So they'll have to slope down that way, and so that when it rains, all this water from here is diverted and it's diverted down that way. So that flashing there has to have an upstand, and then it falls slightly over this way. So when water comes back here, it's diverted this way and then that way and into that internal gutter there. I think for me that is the most immediate solution this guy can do for his construction. Otherwise, I can guarantee that within no time, once the construction is finished, this here is going to be a major point. This here is going to be a major point of weakness and a major point of leakage. It won't take long, probably six or 7 months down the line. And given that right now it's summer in Kenya, of course, the process will be accelerated. Let's see, let's go back to my drawing. Yeah, so basically guys, that is how you design an internal gutter. In certain situations, this wouldn't be tiles, this would be a different sort of cladding. It could be plaster, so waterproof plaster, with the same sort of flashing, and then here we will have maybe a steel flashing, another steel cap flashing, that just helps to divert the water over here. So we'll have something like this ideally, and I'll show you. We'll have something like this over here in normal typical circumstances with a bird's mouth. So we'll have something like that. Get rid of that. We'll have a flashing like that. But then of course, because this is steel, and any time between steel, when you have a situation where you have steel touching onto, I wouldn't have the tiles. Probably this would be plaster or something, so I wouldn't have the tiles. But anytime you have steel and thingy, you will definitely have waterproofing there, some DPC, some form of DPC there. Anytime you have steel connecting onto concrete, so you gotta waterproof that. So I'll have something else there, and this of course will be a bird's mouth as well. So basically this is to divert any water falling from here will come and then it will be diverted straight there, and it will make sure it doesn't fall into the concrete. And this of course will be plaster, some sort of plaster of sorts. Probably just change that into a different color, maybe something like that. Yeah, but you know, there's a typical detail for this. I just adapted this for the Kenyan situation. For that guy, if he's watching, for that young YouTuber, if he's watching, he can try to remedy that serious mistake that the builder, that one of his fundis has done by doing what I've explained prior, by doing this kind of detail. Ideally in New Zealand, this is sort of the typical parapet wall detailing that we do, and I don't see why he cannot apply the same details. So ours is basically on top of that concrete wall, we will terminate it at roof level and then build a timber parapet. or sometimes, I mean, we normally just do because we build in timber, so parapet walls are always timber, and so you've got a timber parapet wall there, and then you've got you so that's your framing. You've got your wall underlay in green. These are vapor barrier, and then you've got your battens, which gives you the cavity. These are cavity battens, so it gives you a cavity that allows airflow, and then between the airflow within the walls, so it makes the walls breathe. And then you've got your cladding, and then you've got the metal cap flashing on top of the wall, and then you've got to put treated plywood again, so at about 5 degrees, that gives you an angle, and then you put your metal cap flashing, which then directs water down, and you can see the bird's mouth situation there on the metal cap. Yeah, so this is your typical parapet wall detail. This is for specifically for New Zealand situations because we build in timber, but this one here is what the mistakes that I've pointed out in this particular house that this young guy is building, and then sort of this is the suggested sort of mitigation solution for him, and if he watches this video, hopefully this one helps him. I will continue sort of looking at this kind of construction and just sort of pointing out some of those mistakes or things that these guys could do better. But there's a lot of them doing these sort of buildings, and I just hope that because they're spending it's a ridiculous amount of money they're spending building these houses. I built a house myself in Kenya, and it was quite expensive, and I remember I literally had to get my builder or fundi on video almost on a daily basis, just trying to explain to them what they need to do. And in doing that, I noticed that they didn't always get it right because I'm far away and way far away as well. So some of the things